Hi friends, in this video we'll be learning about 5 topics under binomial distribution and starting with moment generating function of a binomial distribution denoted by mx of t, and the formula for moment generating function is mx of t is equal to expectation of e power tx, and that can be written as summation of x is equal to 0 e power tx into px. As we all know, expectation of x is equal to summation of x is equal to 0 to n x px. Then proceeding as same, we substitute the value of px ncx p power x q power n minus x. Then as e power tx and p power x has the same power x, we can combine them as p e power t the whole power x same q power n minus x. Then substituting the formula of binomial distribution here, we get nc naught p e power t the whole power 0 q n minus 0 plus nc1 p e power t the whole power 1 q power n minus 1 plus etc. ncn p e power t the whole power n q power n minus n. We substitute these values for x because x takes the values from 0 to n. Then nc naught is equal to 1, ncn is equal to 1, something power 0 is also equal to 1. Substituting these in the above equation, we get q power n plus nc1 p e power t the whole power 1 q power n minus 1 plus etc. p e power t the whole power n. Then again combining these two values, the power n is common, we get q plus p e power t the whole power n. And thus is the formula for moment generating function of a binomial distribution. Then followed by the next topic, characteristic function of binomial distribution, and it is denoted by phi x of t. The formula is phi x of t is equal to expectation of e power I tx. As said before, expectation of x is equal to summation of x is equal to 0 to n x px. Then substituting this here with the value of e power I tx for x, we get summation of x is equal to 0 to n e power I tx into px. Then proceeding as further with the value of px, we get ncx p power x q power n minus x into e power I tx. Then combining these two values, we get summation of x is equal to 0 to n ncx p e power I t the whole power x into q power n minus x. Then substituting the formula for binomial distribution with the value of x is equals to 0 to n, we get nc naught p e power I t the whole power 0 q power n minus 0 plus etc. plus ncn p e power I t the whole power n into q power n minus n. Then substituting the values for nc naught is equals to 1, ncn is also equal to 1, then anything power 0 is also equal to 1. Substituting these values in the above equation, we get q power n plus etc. plus 1 into p e power I t the whole power n. Then combining these two, as they have same power, we get q plus p e power I t the whole power n. And thus is the characteristic function of binomial distribution. Then proceeding with these two results, we know that e of x is equal to np, that is nothing but the mean, and variance of x is equal to npq. These two are constants. Then from e of x by n, we take n outside and we get 1 by n e of x. Then substituting the value for e of x as np, we get p, cancelling n and n. Therefore, e of x by n is equals to p. Then variance of x by n is equals to 1 by n square into variance of x. Again substituting the value for variance of x as npq and cancelling the values of n, we get pq by n. Therefore, the value of variance of x by n is equal to pq by n. Then we use these two in the results 1 and 2 for proving. Proceeding with the first result by substituting the value of p as e of x by n, we get e of x by n minus e of x by n the whole square. This is nothing but variance, and this can be written as e of x by n minus p the whole square is equal to e of x by n minus e of x by n, and that is equal to variance of x by n. Therefore, e of x minus p the whole square is equal to pq. We take it from the above equation. Followed by the next result, covariance of x by n comma n minus x by n. The formula for covariance of x comma y is equal to e of x minus e of x into y minus e of y, and the e outside belongs to both. Considering x by n as x and n minus x by n as y, and then substituting in this equation, we get e of x minus n minus e of x minus n. Then for y value, n minus x by n minus e of n minus x by n. From the above result, we take x e of x by n as p, then separating the value for y as n is common, we'll get 1 minus x by n minus e of 1 plus e of x by n. We get 1 because n by n gets cancelled and gives you the value 1. E of 1 is also 1, so minus 1 and plus 1 will get cancelled, and we get minus x by n plus p, since the value of e of x by n is equal to p. Now taking the minus out, we get x by n minus p into x by n minus p, that is equal to minus e of x by n minus p the whole square. This is nothing but the first result, minus p by q by n. Hence, the second result is also proved. Followed by the next topic, moment generating function about mean. As we all know earlier, the formula for moment generating function is mx of t is equal to expectation of e power tx. As mean is x bar, we can write this as mx minus x bar of t is equal to e of e power t into x minus x bar. The value of x bar, that is mean, is constant, and that is equal to np. Then substituting that and taking t inside, we get e of e power tx minus tnp. Then separating this, we get e of e power tx into e power minus tnp. Taking e power minus tnp outside and substituting the value of expectation of e power tx as q plus p e power t the whole power n, we get e power minus tnp into q plus p e power t the whole power n. Then taking the power n common outside, we get e power minus tp into q plus p e power t the whole power n. Then taking e power minus tp inside, we get q e power minus tp plus p e power t into e power minus tp the whole power n. And combining the value of e's, we get p e power t into 1 minus p. 1 minus p is nothing but q. That is equal to q e power minus tp plus p e power tq the whole power n. We use formulas of e power x is equals to 1 plus x by 1 factorial plus x square by 2 factorial plus etc. And e power minus x is equal to 1 minus x by 1 factorial plus x square by 2 factorial minus etc. And substituting these in the above value, since we have e power minus dp, we use this formula of e power minus x, and that is equal to q into 1 minus pt by 1 factorial plus pt square by 2 factorial minus pt cube by 3 factorial plus pt power 4 by 4 factorial minus etc. Plus p into, we take this formula of e power x, that is equal to p into 1 plus qt by 1 factorial plus qt the whole square by 2 factorial plus qt the whole cube by 3 factorial plus qt power 4 by 4 factorial and the whole power n. Then Taking the square, cube, power 4, everything inside, we get q into 1 minus pt by 1 factorial plus p square t square by 2 factorial minus p cube t cube by 3 factorial plus p power 4 t power 4 by 4 factorial plus etc. plus p into 1 plus qt by 1 factorial plus q square t square by 2 factorial plus q cube t cube by 3 factorial plus q power 4 t power 4 by 4 factorial the whole power n. Then taking the q and p inside, we get q minus pqt by 1 factorial plus p square qt square by 2 factorial plus p cube q into t cube by 3 factorial plus p power 4 q t power 4 by 4 factorial minus etc. plus taking p inside, we get p plus pqt by 1 factorial plus q square pt square by 2 factorial plus p q cube t cube by 3 factorial plus p q power 4 t power 4 by 4 factorial etc. the whole power n. Then by combining these two, plus pqt and minus pqt gets cancelled and p plus q is equal to 1. Then from these two we take pq t square by 2 factorial common. Then we have p plus q. From these two taking plus pq t cube by 3 factorial, we have q square minus p square left. Then from the fourth term we take pq t power 4 by 4 factorial common. Then we have pq plus q cube and writing the whole power n as such. Then substituting values for p plus q as 1. Here we use a square minus b square formula, that is nothing but a plus b into a minus b. So we will be having q plus b q plus p into q minus p. Then for the fourth term we will be using p cube plus q cube is nothing but p plus q the whole cube minus 3pq into p plus q. That is nothing but a plus b the whole cube is equals to a cube plus b cube plus 3ab into a plus b. In the place of a we have kept q and in the place of b we have kept p. That is equal to p plus q the whole cube minus 3pq into 1. Again substituting p plus q is equals to 1 here, we get 1 minus 3pq. Substituting all these formulas in the above equation, we get 1 plus pq t square by 2 factorial into 1 plus pq t cube by 3 factorial into 1 into q minus p. As q plus p is equals to 1, we substitute 1 there. Then for the fourth term we will have pq t power 4 by 4 factorial into 1 minus 3pq the whole power n. Then using 1 plus x the whole power n formula, considering this whole term as x, we use 1 plus x the whole power n. 1 plus x the whole power n is equal to 1 plus nc1 into x plus nc2 into x square plus etc. Now applying this here with the values of nc1 is equal to n and nc2 is equal to n into n minus 1 by 2 factorial, we get 1 plus n into pq t square by 2 factorial plus pq t cube by 3 factorial into q minus p plus pq t power 4 by 4 factorial into 1 minus 3p cube. This is nc1 into x. Next writing nc2 into x square, we get n into n minus 1 by 2 factorial into pq by 2 factorial plus pq t cube by 3 factorial into q minus p plus pq t power 4 by 4 factorial into 1 minus 3pq plus etc. the whole power 2. Now we have to find moments. mu naught is equal to 1, which is a constant. Then mu 1 is equal to the coefficient of t power 1 by 1 factorial. Since we don't have t power 1 by 1 factorial, that becomes 0. Next, mu 2 is equals to coefficient of t square by 2 factorial, and that is equal to npq. We don't have t square by 2 factorial in this term because there is whole square. Next, mu 3 is equals to the coefficient of t cube by 3 factorial. Again, we'll have npq into q minus p. By taking n inside, we get this. Then mu 4 is equal to coefficient of t power 4 by 4 factorial. That is equal to npq into 1 minus 3pq. Then when we square it in the second term, we get n into n minus 1 by 2 into p square q square by 2 factorial is nothing but 2. While squaring it, that becomes 4. But we need t power 4 by 4 factorial. 4 factorial is nothing but 4 into 3 into 2. We have 4 and 2, but 3 is missing. So multiplying and dividing by 3, we get 3n into n minus 1 p square q square t power 4 by 4 factorial. And that is equal to 3n into n minus 1 into p square q square. Then simplifying it further, we get npq minus 3n p square q square plus 3n square pq square minus 3n p square q square. Then combining the similar terms, we get npq minus 6n p square q square plus 3n square p square q square. Then taking npq common, we get npq into 1 minus 6pq plus 3n square p square q square. Then the next topic is cumulants of binomial distribution, and it is denoted by the formula kx of t is equal to log of mx of t. As we know earlier, mx of t is equal to q plus p e power t the whole power n. Then taking the power n in front, we get n log q plus p e power t. Then here we use the formula e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus etc. That is equal to n log of q plus p into 1 plus, since we have t in the place of x, we write t by 1 factorial plus t square by 2 factorial plus t cube by 3 factorial, etc. Now multiplying p inside, we get n log of q plus p plus pt by 1 factorial plus pt square by 2 factorial. Now q plus p is equal to 1. Substituting that here, we get 1 plus pt by 1 factorial plus pt square by 2 factorial plus etc. Now using log of 1 plus x, considering this whole term as x, now log 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus etc. Now substituting this formula here, we get n into, as we have this whole term in the place of x, we write pt by 1 factorial. Just writing x here, only the x term here, we get pt by 1 factorial plus pt square by 2 factorial plus pt cube by 3 factorial plus pt power 4 by 4 factorial plus etc. Then writing the next term by taking minus 1 by 2 outside and x square inside, we get pt by 1 factorial plus pt square by 2 factorial plus pt cube by 3 factorial plus pt power 4 by 4 factorial plus etc. the whole square. Then again for the next term, we take 1 by 3 outside and get pt by 1 factorial plus pt square by 2 factorial plus pt power 3 by 3 factorial plus pt power 4 by 4 factorial the whole cube. Then by proceeding the same procedure for the next term and taking minus 1 by 4 outside and writing the x term as such with whole power 4, and this can be continued further as such. Now as usual, finding moments, k naught is equal to mu naught and that is equal to 0, which is a constant. Then k1 equal to mu 1, which is nothing but the coefficient of t power 1 by 1 factorial, and that can be only taken from the first term and not from the other three terms, because it has square, cube and 4. When it gets multiplied inside, it becomes t power square, t cube and t power 4. Therefore k1 is equal to np. Next, k2 is equal to mu 2, that is equal to the coefficient of t square by 2 factorial. So that is equal to np, because the coefficient of t square by 2 is p, and multiplying inside we get np. This is not applicable here because when the square get inside it becomes t power 4, but we need t square by 2 factorial. So the first term we get minus np square, and that is equal to np into 1 minus p, that is nothing but npq. Then as similarly for k3, that is equal to mu t, that is nothing but the coefficient of t cube by 3 factorial. Then from the first term, the coefficient of t cube by 3 is p, and combining with the n outside gives np. Then from the second term, as said earlier, when the square term gets inside, it is not applicable. So using a plus b the whole square formula, now considering 2ab as it gives you t cube. Now writing this, minus 1 by 2 outside can be written as same 2ab. Combining this gives you minus t square by 2 factorial, but we need t cube by 3 factorial, as 3 factorial is 3 into 2 into 1. We have 2 factorial, which is nothing but 2 into 1. So multiplying and dividing by 3 we get minus 3 and n, which is common outside, taking it inside, 3np square t cube by 3 factorial. Finally we get np minus 3np square. Then from the third term, as there is cube outside, it is not applicable except for the first term. Again we take 1 by 3 p cube t cube by 1 factorial with the n. So we get n p cube t cube by 3. But as 3 factorial is equal to 3 into 2 into 1, only we have 3. So multiplying and dividing by 2, we get 3 factorial in denominator. Finally, it is equal to 2np cube. Therefore, k3 is equal to np minus 3np square plus 2np cube. In simplifying further, by taking np common, we get np into 1 minus 3p plus 2p square, separating 3p as minus p minus 2p and substituting q in the place of 1 minus p. In taking minus 2p common, we get 1 minus p, which is nothing but q. Therefore, that is equal to np into q minus 2pq. Again taking q common, we'll get q into 1 minus 2p. Again separating minus 2p as 1 minus p and writing 1 minus p is equal to q, we get npq into q minus p. Now mu 4 is equal to k4, that is nothing but the coefficient of t power 4 by 4 factorial. But mu 4 is equal to k4 plus 3 mu 2 power 2. From the first term, taking np as usual, then taking pt square by 2 factorial, as 2 gets inside it becomes t power 4. But 4 factorial is equal to 4 into 3 into 2 into 1. We have 4 into 2. So 3 is missing. Multiply and dividing by 3, we get minus 3np square t power 4 by 4 factorial. That is equal to minus 3np square. Now considering from the third term, a plus b plus c the whole square formula, that is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. We consider 2ca because it gives you t power 4. Therefore, it is equal to minus n by 2 into pt cube by 3 factorial into pt by 1 factorial. 2 and 2 get cancelled and gives you minus np square t power 4 by 3 factorial. But we need t power 4 by 4 factorial. As said earlier, 4 factorial is equal to 4 into 3 into 2 into 1. But 4 is missing, so multiplying and dividing by 4, this becomes 4 factorial. So that is equal to minus 4np square t power 4 by 4 factorial. So therefore that is equal to minus 4np square. Then from the last term we consider a plus b the whole cube formula, that is equal to a cube plus b cube plus 3a square b plus 3ab square, and considering a square b because it gives you t power 4, that is equal to n by 3 into 3 into p square t square by 1 factorial into pt square by 2 factorial. 3 and 3 gets cancelled and becomes p cube t power 4 by 2 factorial. But we need 4 factorial, which is equal to 4 into 3 into 2 into 1. We only have 2 factorial, but we need 4 into 3. So multiplying and dividing by 12, we get 12 p cube t power 4 by 4 factorial. So that is equal to 12 p cube. And writing the n, which is common outside, therefore we get plus 12n p cube t power 4. Then from this last term, we take minus n by 4 into p power 4 t power 4 by 1 factorial. But 4 factorial is equal to 4 into 3 into 2 into 1. We need 3 into 2. Therefore, multiplying and dividing by 6, we get minus 6n p power 4. T power 4 by 4 factorial. That is equal to minus 6n p power 4. Then simplifying this equation further by taking np common, 1 minus 3p minus 4p plus 12p square minus 6p cube. Then again adding minus 3p and minus 4p, we get minus 7p. Then splitting minus 7p as minus p minus 6p and writing q in the place of 1 minus p. And taking minus 6p common, we get 1 minus 2p plus p square. That is equal to np into q minus 6p into 1 minus p the whole square. That is equal to np q minus 6p q square, since 1 minus p is equal to q. Again taking q common, we get npq into 1 minus 6p. This is nothing but k4. Now we have to find mu4, which is equal to k4 plus 3 mu2 square. So that is equal to npq into 1 minus 6pq plus 3 into npq the whole square. Again taking npq common, we get 1 minus 6pq plus 3 npq, from which we take 3pq common and get 1 minus 3pq into 2 minus n. Hence the result is proved. Then coming into the last part of this lesson, recurrence relation for cumulants of binomial distribution, where cumulants is denoted by kr and recurrence means consecutive terms. Therefore the formula is kr is equals to d power r by dt power r into log of mx of t. And substituting the value of mx of t and bringing the power n outside, we get n into d power r by dt power r into log of q plus p e power t. Now differentiating both sides with respect to p, we get d by dp into kr is equal to n into d power r by dt power r into d by dp of log of q plus p e power t. Since on differentiating this, t is equal to 0, which is a constant, we have to denote it by writing it in the bottom. Then differentiating this becomes n into d power r by dt power r. Differentiating log x gives you 1 by x. In the place of x, since we have q plus p e power t, we have to write q plus p e power t in the bottom. Q is equals to 1 minus p. When 1 minus p is differentiated, it gives you minus 1. So minus 1. When differentiating p e power t gives you e power t. As p becomes 1. As we are finding recurrence, we have to find the next term, which is k r plus 1. That is equal to n into d power r plus 1 by dt power r plus 1 log of q plus p e power t. And in the bottom, t is equal to 0. Now separating this d power r by dt power r into d by dt of log of q plus p e power t, t is equal to 0. Differentiating this gives you n into d power r by dt power r. Differentiating log of q plus p e power t gives you 1 by q plus p e power t. Then differentiating with t, q becomes 0 and p e power t remains as such. Then this term can be written as 1 minus q by q plus p e power t. And simplifying this gives back you the same term. After cross multiplying, q plus p e power t minus q by q plus p e power t. After cancelling q plus q and minus q, we get back the same term. Then write t is equal to 0 as it is a constant. Then multiplying d power r by dt power r inside, we get n into d power r by dt power r minus d power r by dt power r into q by q plus p e power t. Differentiating 1 gives you 0, so it becomes n into 0 minus d power r by dt power r into q by q plus p e power t, and in the bottom t is equal to 0. Now taking minus q outside with n gives you minus nq into d power r by dt power r into 1 by q plus p e power t, t is equal to 0 at the bottom. Therefore, this is the value of k r plus 1. Now k r plus 1 minus pq into d by dp of kr. We have to find this, and that is equal to minus nq into d power r by dt power r into 1 by q plus p e power t minus npq into d power r by dt power r into e power t minus 1 by q plus p e power t. Now taking the common terms outside, we get minus nq into d power r by dt power r. We have only taken minus nq common and we have p left over in the second term, so we will get 1 plus p e power t minus p by q plus p e power t, which is common, and at the bottom t is equal to 0. Therefore, that is equal to minus nq d power r by dt power r. 1 minus p is nothing but q. Since these two terms are similar, these two terms get cancelled, and d power r by dt power r into 1 is nothing but 0. Therefore, finally, kr plus 1 minus pq into d by dp of kr is equal to 0. And that is equal to, when this minus term goes to the other side of 0, becomes positive, and kr plus 1 equal to pq by d by dp of kr. As usually, finding moments, K1 is equal to NP, which is equal to mean is a constant. From this we find the other terms K2, K3 and K4. K2 is equal to PQ by D by dP of K1. This is taken from the above equation, and that is equal to PQ into D by dP of NP. Differentiating NP gives you 1 after taking the n common outside. Therefore, this is equal to NPQ. K3 is equal to PQ into D by dP of K2. K2 is nothing but NPQ, and taking n common outside, then substituting the value of PQ as 1 minus P, then multiplying P inside gives you D by dP of P minus P square. Differentiating now gives you NPQ into 1 minus PQ. Again, minus 2PQ can be written as minus P and minus P. Writing Q in the place of 1 minus P gives you NPQ into Q minus P. Finally, K4 is equal to PQ into D by dP of K3, that is nothing but PQ into D by dP of NPQ into Q minus P. This is equal to PQ into D by dP of NPQ. Instead of Q, writing 1 minus P, then taking n common outside gives you NPQ into D by dP. Again writing 1 minus P instead of Q, and combining minus P gives you minus 2P. Multiplying all terms, then finally this gives you NPQ D by dP of P minus 2P square minus P square plus 2P cube. Adding minus P square minus P gives you P minus 3P square plus 2P cube. Now differentiating, this becomes 1 minus 6P plus 6P square. Taking minus 6P common gives you NPQ into 1 minus 6P into 1 minus P. Nothing but Q. Therefore, this is equal to NPQ into 1 minus 6PQ. Hence proved. Thank you.